Hello students, we are meeting for our next lecture of cement and glass industry. In the last lecture we have finished cement. Now today we'll start with the glass industry. Okay, so glass has uh, a very old, you can say, history, and nearly 6,000 years ago ancient Egyptian know how to manufacture the glass, and approximately 20 centuries ago the temple of Belus in Egypt was constructed with bricks colored with glass enamels. So enamel is also hard substance like glass. Afterward, Alexandria became the center of glass industry. So that is the history. Even ancient Hindus knew how to make the glass long before the Christian era. And the first glass factory in India was started in 1856 in Buldana district. And the term glass means it signifies it is a liquid, super cool liquid to such an extent that it becomes the apparently a transparent solid. So it is amorphous, hard, brittle, usually transparent, super cooled solution of silicates and borates of potassium, calcium, and lead. So these are the constituents of a glass. So ordinary glass is obtained by fusion of sodium carbonate, calcium carbonate, and sand. It gives rise to mixture of fused silicate. So when a fused mixture of these silicates are cooled, it forms homogeneous solid mass without allowing any of the these constituents to crystalline. Glass is not a crystalline; it is an amorphous, super cooled liquid. So, on the basis of various parameters, glass is defined in uh, three ways. Okay. So, general definition of glass, it can be defined as amorphous, hard, brittle, usually mixture of alkali metal silicates, for example, sodium and potassium, with the alkaline earth or heavy metals silicates like calcium or lead type of silicate, which is produced when liquid melt solidifies without undergoing crystallization. So depending on the properties of glass and composition, this definition is given. So it is a mixture of alkali metal silicates, then heavy metal silicates, alkaline earth metal silicates, and even it is melted and then it is produced when liquid melt solidified without undergoing crystallization, means it is amorphous. Then it can be defined on physical basis. Physically, glass can be defined as a rigid supercooled liquid having no definite melting. Because of amorphous nature, it doesn't have any uh, fixed melting point, and it possesses the sufficiently high viscosity to prevent crystallization. Okay, so crystallization is also not possible because of high viscosity. Then same glass can be defined on chemical basis. It can be defined as the union of non-volatile inorganic oxides. Okay, union of non-volatile inorganic oxide resulting from the decomposition and fusion of alkali and alkaline earth compounds. Okay, so what is it? It is a non-volatile inorganic oxides, okay, and which are resulting from decomposition and fusion of alkali and alkaline earth metals, sand, and other constituents giving random atomic structure. Okay, so this is the chemical definition of the glass. Basically, glass is super cooled liquid. It is amorphous in nature. It is transparent. Mostly, it is transparent. It may be colored. So that is the definition of glass. And the silicates of alkali metals, alkaline earth metal, or heavy metals are used along with other coloring oxide. Okay, then what is the importance of glass material? So all of you know glass has many uses. This is due to transparent nature, that is the first thing. High resistance to chemical attack, that is one more feature. Then potency as an electrical insulator. So glass is fragile, hard but easily broken. Okay, and it typically shows compressive strength considerably greater than its tensile strength. It doesn't have tensile strength, but it has compressive strength. So about 800 different glass compositions are manufactured depending on their properties and uses. So that is the importance of glass. All of you know where the glass is used, with vehicles, cars, in construction for windows, or sometimes in your furniture, or it is used in as a containers many times, bottles. Okay, you must have seen bottles, glass bottles, and apart from that, even your mobile is covered with Gorilla Glass. So most where there is a widespread applications of glass material, so its importance cannot be neglected, and that's why we're studying it under the industrial. So what is the basic composition of the glass? Okay, so all variety of glass contains silica. That is the very common. Common soda glass contains sodium and calcium silicate. It has approximate composition of sodium oxide, calcium oxide, and silicate. So, in addition to, or in place of sodium oxide and calcium oxide, special glasses may contain some important constituents which affect the property of glass. Means mostly it is a silica and silicates of alkaline metals, alkaline earth metals, or heavy metals. So basically, silica is very common to all classes. So what are those common composition factors? These are these. First is potassium oxide. So it increases softening of glass and mobility of liquid. It also increases the melting point of glass. Then second is ferric oxide. Ordinary glass contains little amount of ferric oxide, and glass cannot transmit ultraviolet rays if it contains Fe2O. That is very important. That's why it is used in physical chemistry, especially spectrophotometric experiment. It contains more, if it contains more amount of ferric oxide, nowadays quartz glass is used to prevent transmission of ultraviolet radiation. Means it can be used to make the specs also, so that it will be, our eyes will be protected from ultraviolet rays. Then next is litharge. Okay, lead oxide. It increases the refractive index of glass, and such glasses are used in optical fiber. Okay, so optical fiber can carry light like a liquid because of high refractive index of the glass that is achieved by lead oxide. So it promotes fluidity of molten glass, so the workability of molten glass is increased. That is very important feature. And last is boron oxide. It increases the hardness and refractory nature of glass. That's why borosilicate glass material glass is used to make the laboratory glasswares. In lab you must have heard borosilicate glass. You can use for carrying very concentrated or very reactive reagents. At the same time you can heat it to very high temperature. So all these are very you can say protective for this very high heat and various reactive reagent. So it increases the hardness and refractory nature of the glass. So it acts as a fluxing agent for silica. Such glasses have low expansion coefficient, so it does not break very easily whatever you may heat. So it is resistant to shock, chemical stability, and high electrical resistance. So such glasses can withstand sudden change in temperature. That's why after heating, if you cool, it doesn't break very easily. So that is called as hard glass test tube. Okay, so therefore it is used in laboratory glassware, insulators, pipelines, washers, thermometers, lamp chimneys, and minor lamp glasses. So these are the basic composition of glasses. Then next is structure of glass. Glass can be in two forms, that is a crystalline as well as amorphous, that is glassy state. Okay, and the comparison as usual, you know, crystalline has arranged two-dimensional structure, order structure, whereas in glassy it is not so. So due to random nature of glassy state, fracture cannot be predicted, whereas here you can in crystalline easily you can find out the fault line and you can predict the fracture also. So these are the two types of glasses on the basis of structure. Then we'll discuss some physical properties of glass. There are some general physical properties. So it is not actually we may feel it is solid. It is not solid. It is very super cooled liquid which has no fixed melting point, and it is transparent amorphous solid. Okay, and on heating it gradually softens, means it has no fixed melting point, so it softens slowly and then melts over a wide range of temperature into mobile liquid. And this glass is hard and brittle. Okay, so it's amorphous solid and therefore it breaks. That is, it is a brittle. Okay, then it is a bad conductor of heat and electricity. That is very important, and it acts as an insulator. Okay, and glass is practically insoluble in water. Directly, it doesn't soluble, but what how it affects that we'll see in chemical property. Then one more physical property is vitrification. What is vitrification? Glass on fusion form transparent mobile liquid, which on slow cooling forms amorphous solid. This process known as vitrification. Okay, so that is the physical property of glass. Then next is devitrification. What is devitrification? Glass has tendency to of losing its transparency and becoming opaque due to crystallization of component silicate. This is known as devitrification of glass. So crystalline is possible because of defective annealing and slow cooling process. Means if it is a transparent glass, then it is vitrified glass. If it is non-transparent, opaque, then it is devitrified glass. Then next is isotropy. Glass possesses similar properties in all possible directions, and therefore it is called as isotropic. So there are isotropic properties and isotropic properties. All of you know in physical chemistry. Same isotropic properties are exhibited by glass. Then glass has important property of becoming plastic on heating. Means it becomes plastic, and it can be blown, molded, or rolled into sheets that we are going to discuss. And because of this plastic nature, all these shapes are possible. So molten glass slowly solidifies on cooling without showing any tendency for crystallization. So this is the and then the very important property, that is transparency of glass, and it can be preserved even when coloring materials are incorporated. Means you can have colored glass, but that is also transparent. So these are the various physical properties of glass. Then we'll move ahead to the chemical properties of glass. Glass is not attacked by air or oxidizing agent. Means normally glass does not react. Okay, then second is ordinary glass is attacked more easily by alkaline solution than acid solution. This reaction takes place at room temperature, and if suppose for example if you fill up the burette with a dilute solution of sodium hydroxide or potassium hydroxide and keep it for 1 day or some days, the stopper cork stick to the socket and it becomes difficult to open. Okay, so that means it reacts with the glass. So strong acid removes alkali from surface of glass. Means then that choking can be removed by applying acid. Okay. Then next is reaction with water. Just now we discussed. So ordinary glass is alkaline in nature. So it is a salt of strong base and weak acid. Weak acid is silicic acid, and strong base is calcium or other carbonate. So glass slowly reacts with water and leaches out sodium silicate. The sodium silicate is called as water glass, which is soluble in water, and it forms the soda lime glass. Sodium silicate on hydrolysis forms sodium hydroxide and silicic acid. Pyrex glass is a neutral glass and cannot be attacked by water even with contact for prolonged time. So normally with water leaching reaction takes place. Okay. So but directly water immediately does not react, slowly it reacts with water. Then very important is reaction with acid, especially hydrofluoric acid. Since glass is mixture of alkaline metal silicate, alkaline earth metal silicate, and free silica, it reacts with HF, hydrofluoric acid, to form soluble compounds. So what are those reactions? The reaction is like this. So it reacts with HF and form fluoride salts, and these are soluble. So that part which reacts with HF can be easily carved out. So that's why HF is used for etching process. If you want to etch out a name or design on glass, hydrofluoric acid is sprayed accordingly, and after some time it is washed out, so that that much part where the HF is sprayed, that glass is etched out, and you can see that design. Okay. Then next is glass can react with fusion mixture. It is a mixture of sodium carbonate and potassium carbonate. So when it reacts with fusion mixture, so these alkali silicates and carbonates of calcium and other metals are formed. That is the first thing. Okay. The resultant mass is cooled. It is then treated with JCl when silicic acid and chlorides of metals are formed. Okay. And this the mixture is evaporated to dryness. It is baked for 15 minutes. It is extracted with water and dilute HCl and filter. On filter paper, silica is left as residue. Okay, so it is formed due to dehydration of silicic acid, and metallic chlorides remained in filtrate. Means silicates and carbonates get totally removed, and you get silicic acid and metal chlorides. Okay, so these are the reactions, or you can say chemical properties of glass. Then the next part is classification of glass. Glass can be classified into various types, as per given in the book. There are 8 types, and their properties and their uses all are mentioned. There is nothing to explain, just you go through and read it from the ready material which I have given. We'll move ahead. Very important part of this chapter, that is manufacture of glass. For manufacture of glass, there are you need a raw material for making glass. So what are those raw material? In that, first is principal raw material. What is that? First is acidic oxides. What are those acidic oxide? Silica, boric acid, calcium phosphate, and arsenious oxide. So these various oxide gives various properties to the glass, and depending on their property, you can depending on what kind of glass you want to make, you can change the composition of these material. But mostly sand remains common, because silica is the basic constituent of glass. As you know, borax gives the hardness and resistivity to the heat shock, and depending on your requirement, you can add borax. Calcium phosphate gives bright appearance. Arsenic oxide gives color to the glass. So depending on the requirement, you can change. If you increase the amount of silica, it can help to transmit only UV rays in presence of sunlight. So depending on your application of the glass, you can change the composition of these acidic oxide. There are basic oxides also, like soda ash, potassium, limestone, barium carbonate, dolomite, litharge, and zinc oxide. As I told you, again, these are also give various properties to the glass. um, uh, so depending on the requirement, you can change these compositions also. So what do you want? What is the purpose of role of that glass? Depending on, you can change the various compositions. You can read it from the book also. And then the next part of this raw material is coloring material. Okay. So if you along with alkali metal oxides and alkaline earth metal oxides, just now I told you, you can add heavy metal oxides, and these are acting as coloring metals. The list is given here. If you are depending on your requirement which color you want, you can add any of these metal oxide. For example, if you add manganese oxide, it will give purple color. If you add copper oxide, it gives peacock blue color. And depending on your requirement, you can add the coloring material. At the same time, during reaction, it may impart the undesired color, so you can use decolorizers, and these decolorizers are oxides of manganese, arsenic, antimony, nickel, or cobalt can be added in large amount to molten glass for decolorization purpose. And the last is flux. Flux changes the melting point of the material. So this here in this case of glass, it is oxide of boron, that is boron B2O3, or sodium nitrate, potassium nitrate, sodium sulfate, antimony oxide, arsenic oxide, and borax acts as a flux. So sodium aluminum silicate nepheline flux is added in glass to increase alumina, or you can add fluorospar flux. It added in enamels or glass. It introduces, if fluorine is introduced in this material. So these changes, fluxes, the role of flux is to change the melting point. Okay, and the last raw material is chelate. What is chelate? Many times this question is asked, what is chelate? Chelate is nothing but it is a crushed glass or broken glass pieces obtained from imperfect or defective articles. Means this is a raw glass in the form of small pieces, and it facilitates the melting of glass and utilizes the waste material. Means at the same time, it is a, you can say, it is a recycling of uh, faulty glass or used glass. Okay, and it used to maintain the melting point. The proportion of chelate used varies widely from 10 to 75. So these are the raw material which are necessary for manufacture of glass. Okay, now we'll stop here. We'll discuss in next lecture the how glass is actually manufactured. Okay, so for time being, we'll stop here. Thank you.